Okay, last one, last page. So solve the equation and check the solutions, right? So let's just jump right in and start. So dealing with these rational equations, not rational, dealing with these radical equations, I need to get rid of the radical. See, there's a variable under the radical, and I can't really do anything with it because the variable under the radical can't interact with the stuff that's outside the radical. So I need to get rid of the radical. Well, that radical is a square root. So if that's a square root, right, I need to do the opposite or the inverse operation of square root, which guess what? Is square or taking something to the second power. So I isolate my radical, and then I just start taking the square root, or I'm sorry, the square. So 35. So I'm going to take that to the second power, and then I'm going to take 7 to the second power. Because remember, when I have an equation and I do the same operation on both sides, it doesn't change the overall value of the equation. Now, on the left, the square root and the square, they cancel each other out, so I'm just left with x plus 35. Now, on the right side, I got 7 to the second power. That's 49. So now I just have an equation, so I solve it. So I subtract 35 from both sides, and I have x equals 14. So now I take that 14 and plug it back into my equation and see if it gives me a viable answer. So the square root of x plus 35 equals 7. So that's the square root of 14, because that's what I got for x, plus 35 equals 7. So 14 plus 35 that's the square root of 49 equals 7. And square root of 49 is 7. 7 equals 7. Yes, that is a viable answer. I'm done. Okay, so next, let's look over here. I want to isolate my square root. It's got a 2 in front. That's a 2 times my square root. So guess what? That ain't isolated. So how do I get rid of this 2? Well, this 2 is being multiplied times my square root. And what's the opposite of multiplication? Division. So I'm going to divide by 2 on both sides. These 2's cancel each other out. 2 divided by 2, right? And so now I'm left with x plus 10 under the square root equals 8 divided by 2, or 4. Now I've isolated my square root. So now I can take it to the second power to cancel it off, to get rid of it. I just got to remember that I got to take the right side, or this 4, to the second power. So now the square and the square root cancel each other out, and I got x plus 10 equals 4 to the second power, 16. So now it's just an equation. Subtract 10 from both sides. X equals 6. So now I need to go back to my original equation. X plus 10 equals 8. So I need to plug in 6 there. So 2 times the square root of 6 plus 10 equals 8. 2 times the square root of 16 equals 8. What's the square root of 16? 4. 2 times 4 equals 8. 8 equals 8. Yep, done. I meant to make that red, oh well. So, yep, viable answer. Next problem. So now I'm looking at this one. I need to isolate my square root, so I need to get rid of this 5. So let's rewrite it, and then we'll work on it. So let's start by subtracting 5 from both sides, and I've got the square root of x plus 3 equals negative 13. I can stop right here and know that there's going to be no solution. Now, when I say I could stop, I'm saying I could, but I'm not, because I need to show my work. But if I have a square root equals a negative number, there's no solution. Okay, there's not. It seems kind of weird the way square roots work, but when I'm working with a square root that's an equation like that, a square root, I only think about outcomes being positive. Well, let me just explain what I mean by that. If I take the square root of 9, the square root of 9 is 3, right? Because 3 times 3 is positive 9. The thing is, though, negative 3 times a negative 3 is also positive 9. So if I take the square root of 9, The answer is actually positive or negative 3. But see, when we're working with variables like this, we don't do that. We only stay with the positive version, the positive number. So I'm thinking x plus 3 whatever equals, if it's going to equal a negative, then I got a problem, right? So I'm just going to say that up front, but we're going to work it out anyway. So now that I isolated my square root, I'm going to take it to the second power, and I'm going to take negative 13 to the second power. That's x plus 3 equals, because remember, the square and the square root cancel each other out. Negative 13 to the second power is 169. Yes, I'm a math teacher. I know what 13 times 13 is. So now that I got that, now I'm just dealing with the equation. So I subtract 3 from both sides, and I got x equals 166. So now I need to plug 166 in here. So let's plug it in here. So I've got the square root of x plus 3 plus 5 equals negative 8. So I'm going to plug in. So the square root of 166 plus 3 plus 5 equals negative 8. So that's going to be the square root of 169 plus 5 equals negative 8. So the square root of 169, it would be positive and negative 13. But because we're working with variables, we're only going to stick with the positive side. So that's going to be 13. So 13 plus 5 equals negative 8. No, it don't, because 13 plus 5 is 18. 18 don't equal negative 8, so this is no solution. Okay. So next, let's go to this one. So I've got negative 6 times the square root of x minus 13 equals 30. And let's get rid of this. All right, so I need to isolate my square root. So that isolating my square root means that I need to get rid of that negative 6. So I'm going to divide by negative 6 on both sides. So I'm going to get the square root of, let's make sure I get it right, x minus 13 equals negative 5. Well, again, I'm in that same situation that I got a negative, a square root equals a negative. So I already know it's going to be no solution. You still need to work it out because you need to show your work. But just so you know, once you see a square root equals negative, you know there's no solution. So anyway, so now I isolate this. Now that I've isolated the square root, I can take the square of both sides, and that gets rid of that square root. And then negative 5 to the second power is 25. And then I add 13 to both sides. And I get x equals, what is that, 38? So now let's give myself another. All right, so I've got negative 6 times the square root of x minus 13 equals 30. So now I've got negative 6 times the square root of 38 minus 13 equals 30. Negative 6, 38 minus 13, that's 25. So the square root of 25 equals 30. Well, the square root of 25, I know what it is. It's 5. So negative 6 times 5 equals 30. Negative 5 times 6 is negative 30, my guy. And negative 30 does not equal positive 30. So there's no solution for this. Two more problems. So let's hurry up and get out of her. So I've got the square root of 4x plus 5 minus 1 equals 8, right? And so what's the next thing I'm going to do? I'm going to isolate my square root by adding 1 to both sides. So now I've got the square root of 4x plus 5 equals 9. So now that I've isolated it, now I'm going to take the square of both sides. All right, so taking this to the second power eliminates the square root. So I got 4x plus 5. And then over here, I've got 9 squared. 9 squared is 81. So now I just have a two-step equation. Subtract 5 from both sides, and I get 4x equals 76. And then I divide both sides by 4. X equals, let's see, 4 goes in there one time with 3 left over, goes in there 19 times. Bada boom, bada bing. So now let's see if this works. So I've got the square root of 4x plus 5 minus 1 equals 8. So now I'm going to replace. So I've got the square root of 4 times 19 plus 5. It's all under the square root. Minus 1, which is not, equals 8. Now, when I look at that, 4 times 19 is 76, just like we did down there. Plus 5 minus 1 equals 8. That is the square root of 81 minus 1 equals 8. Square root of 81 is 9. So 9 minus 1 equals 8. 8 equals 8. Yep, yep, yep. All right, last problem. So I've got the square root of 12x minus 23 plus 1 equals 11. So let's rewrite it. Square root of 12x minus 23 plus 1 equals 11. So I need to isolate the square root, so I'm going to subtract 1 from both sides. So I got the square root of 12x minus 23 equals 10. So now I've isolated it, so the square root of 12x minus 23, taking that to the second power, equals 10 to the second power. So the square and the square root cancel each other out, so I got 12x minus 23 equals 10 to the second power, which is 100. So I add 23, both sides, 23, not 22. And now I got 12x equals 123. I divide by 12 on both sides, and I get x equals 123 over 12. Now, 123 over 12 can be reduced. 12 doesn't go in there evenly, but 12 can be divided by 3, and 123 can be divided by 3. Now, if you can't see why that is so, there's a trick for division. If you have a multi-digit number and you want to know if it's divisible by 3, separate the digits. So it's 123, so 1 plus 2 plus 3, that equals 6. If this sum is divisible by 3, then that whole number is divisible by 3. Don't ask me why it works, but it does. So because 6 is divisible by 3, 123 is divisible by 3. So I'm going to divide both the top and the bottom by 3, and I'm going to get 41 over 4. And that's my answer. Now this is where it's going to get tricky trying to have to prove it, make sure that it's okay. But I mean, we can. It's just going to be a little tricky. So let's see. I kind of ran out of room here. So the square root of 12x minus 23 plus 1 equals 11. So the square root of 12 times 41 over 4 minus 23 plus 1 equals 11. So 12 times 41 over 4. I can do some cross canceling here. 4 and 12 can be divided by 4. So if I divide the bottom by 4, I get 1, and 1 on the bottom of a fraction just kind of falls off because anything divided by 1 is just that thing. And if I divide 12 by 4, I get 3. So I'm going to end up with the square root of 3 times 41 minus 23 plus 1 equals 11. So now I got this. 3 times 41 minus 23, all under the square root, plus 1 equals 11. So what's 3 times 41? That is 123 minus 23 plus 1 equals 11. So when I do that, I get the square root of 100 plus 1 equals 11. The square root of 100 is 10. 10 plus 1 equals 11, and then 11 equals 11. Oof, that was a lot, but yep, that worked out. So that's all 3 pages, and I am out of here.